in academic institutes, how they are really flourishing in measurements and manufacturing, he will be the right person to answer those type of questions. So therefore, I requested sir to address in this respect. And when it comes to the academic challenge, I have two wonderful people, Professor Somsegaran Rao and Professor S. Raghavan. So they will be addressing the issues of academic research, especially in the field of antenna. So that way, if you see, things are taken care. The industry expert could not reach from Mumbai because he is busy with that Airtel business. Otherwise, I was thinking I'll tag one of the communication industry person. So because he discussed this, lot of discussion was with him regarding the Airtel requirement or personal communication antenna. Actually, he is my student, but he was in US. So after coming back, he is now holding a very big position. He is the RF head of Maharashtra Goa, the big division. So, and in 4G also, before time he implemented in Chandigarh. So he's very aggressive RF engineer, but he could not make it today because of the company pressure. But anyhow, we have ourselves a good galaxy of the eminent experts. So take advantage of these things. Sir. With this, I request now Professor Ramesh Gaur to take over this chair as chairman of this open session.
Thank you, Professor. I think I need to correct ourselves that I am not the chairperson, I am the coordinator. Okay? We start this session. We have 8 persons, including myself. So I think we should devote most of the time to take it, to address your problems, the audience problems. So I would suggest that each speaker will be given 5 minutes. Each, that means around 40 minutes for the speakers on the dais, and rest of the time is available to the audience. I think that's okay. So maybe which side we should start with? We start from this side. Hello, Professor Raghavan.
Good afternoon to everyone. I would like to tell some of my experience regarding a student's way of designing antennas. Most of the students, what they keep doing is most of the lab have got CST, fidelity, IECD, HFSS, ADS, everything. They keep on do the design by trial and error method. They sit for 4 days, 5 days, a whole week, and then say the moment they get the good answer, they say optimized, and that is not the correct procedure. What I feel, every antenna has got the another name for lambda by 2 is called a resonator. It is mainly meant for resonant phenomena, and it's not that always lambda by 2 is a resonator. You can have lambda by 4 by short or open. You can make it resonate. In any case, basically it is lambda by 2. And then you should know how to get the correction factor. It should not, everyone should not keep on repeat the same numerical and denominator everywhere. They should know how to get that delta L. For that, they should be aware of all the types of discontinuity. In fact, if you take a single patch antenna, it has got so many types of discontinuity. In one way, it has got step down discontinuity. In another way, it has got open end discontinuity. Somewhere you have a gap discontinuity also. So if you are very good in discontinuity analysis, you can even find out what is the delta L correction factor. So that way it will be very nice if you are very good in the analysis, and you can go by optimization directly by theoretical method. Then you can make use of the software and then verify whether it has come out nicely. In fact, many of the journals or even the conferences, they don't accept the answers. You give the answers directly from the software alone. If you go from the theoretical one, from my side, I feel if one can do with MATLAB, do the analysis, maybe just for beautification or decoration, you can go for GUI. Otherwise, technically, MATLAB can do most of the things. So that way, what I want to stress is, students should design from the basic principle so that they can easily find out. And they should never do by trial and error method. Then they should pinpointedly say, this is the answer, this is the analysis, and then maybe they can make use of the software to verify that. Maybe the people, ISRO and other people, where they don't find time, where the time is a constraint, they can go for a software. But as a student, you should know how that software is being written. Is it method of memories or FTTD? Yesterday, Professor Garvey has told very nicely from the basic, the FTTD analysis. So that way, from the basics, you should start writing your own coding, and nothing is equivalent to that. So in that way, as far as the students are concerned, I can mention two books. There are many books for analysis in electromagnetics. As far as planar techniques is concerned, it's nothing new for many other stalwarts. I would say Ito book, planar numerical techniques for planar micro and millimeter techniques. That is one. The next one is the book edited by Sorrentino. These two are purely for planar techniques. So one should be good in method of moments, FTTD, method of lines, transverse resonance techniques. Write your own coding, then you are the master. Because each of the software is based on each technique only. Method of moments, IE3D. So that way each one is based on each analysis. So one should become a master in the numerical techniques, and that way use your own coding, write, get the result, then do the analysis. Then that is the best practice. Then another thing, morning, I should not poke my nose in that. Dr. Vinay told about, Dr. Alphones told about these splitting resonators. So it will be very nice if the gap spacings are given, how to get LNC, or if LNC are given, how to get the spacing and the gap. So that way, for everything, you should find out the reason, not by trial and error method. And I feel these two are normally, in fact, it's a success for the antenna week organizers that this much strength have come. So slowly the interest towards RFL microwaves are increasing, and mainly because of, in fact, there's one article. The name of the article is "Class Cancer: Why People Don't Like Electromagnetic Waves." It's mainly because of the vectors. If you want to understand the concept, I feel you can go by transmission line approach. In that case, you can understand each and every design part, and you can even create interest in that and do wonders in the design. And acceptance of the papers and journals, conference also, rate will be very high if you do your own coding. This is my what all I want to tell about designing of antenna academically. Yeah, we have seen that last 2 days, I think. Many concepts on antennas have been discussed in depth. And as we know that antenna is one of the essential elements. Right? Normally I ask my students, because 10 years back when I teach some of the MIC design, micro integrated circuit design, I take a phone, because that time the phone is projected with the antennas. Nowadays, there is no antennas projected out of the phones. Then I ask, is the antenna is inside? Some students say yes, some students say no, because the antenna is not seen. So that kind of understanding they have. Though they use mobile phones every time, sending SMS, texting it to some of their friends, but they don't know that what is inside. Okay. So basically, I ask them, as an electrical engineering student, you should know. You're not a material science student, you're not a biological science student, so you should have a little understanding on them, on what you're using it, how it operates, or how it works. Coming to this antenna technology in Singapore scenario, that's a global effect also. Not many come towards antennas or microwaves, because they feel that when they see the curl itself, they totally become aversion towards that and then go away, because they are quite comfortable with Java programming or C++ and what else. Okay. But still we find some students who are really keen on that, try to attract them, and then we try to pitch them at the right level, to their bachelor's level or master's level or PhD. Okay. So if you pitch them at the right level, and then if they're able to understand the concepts and then come out with a little patient towards that, then we can really extract a good amount of work from those people. And in Singapore, I think not many private industries sponsor on this research, but mainly we depend on the government organizations. One of the organizations is the defense organization, DSO, Defense Science Organization, which generously supports the microwave area of research. So we always go to them, and if there's a problem is really worthwhile to them, and then even if it is a new idea, it's not really going to make any real output at this stage, but a kind of a novel idea to be tried. They have a various schemes. They call the MINDEF program, Ministry of Defense program. So they have give a small amount of money to have some kind of a pilot program. This is for 1 year. You can try your approach, come out with the results, and prove them that this method will work, and then they can go for a large-scale support of 3 years projects. Okay, that's called the Defense Innovative Research Projects, the ARP. Okay. So main source for our antenna research is DSO, and the other support is basically from the Ministry of Education. That's normally an academic research. That also we do it, and we have various types of grants like a Tier 1, Tier 2, Tier 3 grants at various levels. Tier 1 is mostly supported for the young faculties who have joined just recently and then want to explore for kind of a startup grants. Tier 2 and Tier 3 for the senior faculties. That varies from $500,000 to $1 million. And the other type of grants are the huge grants which is coming from the competitive research proposals, which is also from the National Research Foundation. That's very difficult to get it because we have been trying it. I tried a couple of times, but it is not successful because of it is a conventional area. They always want to have some kind of a commercial flavor to that. So the various agencies really looking forward to support. If you have got any novel idea and which can have some kind of commercial flavor to that or commercial application. Singapore is always business-minded, and whatever you propose, they see the deliverables and the relevance to the industry. And if you can partnership with any industries, that's always a credit to our proposals. So we always look for a organization which can support our research at the post the project phase. That's the way the Singapore, the microwave research in antenna research has been going on for a while. Otherwise, academically speaking, as I mentioned that the students, we need to really motivate them. And most of them are dependent on this kind of tools. As Professor Raghavan mentioned that we have to give a bachelor students, I don't expect to go into the field theory because then nobody will come towards the microwave domain. So just give them to explore these tools, and let's have a little understanding on them, how it works, and then how you interpret these results. Okay, that's fine at the bachelor's level. Then when it comes to the master's, a quasi approach, that a partial simulation based approaches, and then partially the field theory or developing their own code. Okay. But for a PhD, definitely not just by simulation tools. They had to go for field theory. That I keep it as a point, and then they have to do at least 1 or 2 chapters work on the field theory. They have to do some analytical work, understand the structure, understand the physical behavior of the structure, so that the PhD is not the end, right? That's the beginning only. So I always say them, getting the degree is not the end. That's where you're beginning your research work. So after the PhD, they should come out with the more aggressive work on this direction. So I always motivate them to go this kind of bachelor's level, master's level, and then PhD level. Okay, so that's about it.
Just 1 minute. In order to focus this discussion, I would suggest the speakers to address either the future antenna research or maybe something to do with antenna education or a combination of the two. Dr. Das.
Thank you, Professor Gaurav. As I mentioned during my speech, some of the antennas which I just put up to all of you. we study in future. One is a shared aperture antenna. It has got big application, big future. It has just come and people are realizing its importance. So I request all of you to just see on this part, shared aperture antenna. And there is a multi-functional antennas also there. Of course, this work has been done earlier, but the applications people are finding it now. So multifunctional antenna is another area. And another is a digital beamforming array. It's on the line of healthcare antennas. This is another idea you can think of. And IEEE digital library will be helpful to you. When the internet also will get lot many papers, information on this. I request you all to study these areas. It will be helpful for the country. It will be first of all helpful to you, your organization, and helpful for the country and everybody. And there is another idea like radome with frequency selective services. So it is for strategic applications. We have to see how FSS can be built into radome and how it can be made useful, particularly for airborne applications. These are the few things I would like to put across to you for your thinking in the future and also gathering information so that next time when you meet, I am sure you can come out with some papers. Even if some theoretical papers are available, that also will be highly appreciated. I look forward to meeting again with all these new ideas. Thank you.
Okay. Good afternoon, everybody. First of all, I would like to thanks to Adem to invite me to this great event, and thanks to Professor Greg to host this section. And let me introduce myself briefly. I'm Professor Ma, coming from Taiwan. You know, Taiwan has a strong industry related to commercial electronics or something, and antenna is a key component in it. Okay, and myself is a guide between the antenna and between the circuit. So actually, I always take a way to integrate the antenna and the circuit. That's what I would like to present tomorrow morning. And also, I'm currently now is associated over antenna propagation, wireless propagation layers. So actually, I have read a lot of papers. So from this experience, I conclude like actually, I just currently I'm now in Taiwan. I'm engaging in some planning for our country for the next generation in the telecommunication or in the antenna. And actually, I just discussed with some of my colleagues. And we both agree, like actually for the antenna, especially for the when we go to the APS, I mean the APS in the United States, we both has feelings or some agreement, like actually the antenna guys actually in the recent few years we have some challenge or we have some bottleneck. Actually, I will use the term bottleneck. Yeah, because actually, you know, the software has been so matured, and everybody, if you have a chassis, for example, like an iPad or something, and you cut some metals on it, it becomes an antenna. So I think we should take the opportunity to re-emphasize like what is the value of antenna engineering and what is the art or what is the re-emphasize the importance of antenna, especially behind the work. For me, as an associated over at the AWPL, actually, I'm put much more emphasis on why you design antenna. Why you submitted your antenna to this later? So you must tell me why, not just the tuning process or just not the the results. Even your results and the measurement agree with each other very well. And I would like to ask you, and the reviewers, generally my reviewers will ask you why you have such a result, even if it's a good result. So it is our job in the when we look into the future. And I think that for the future, for the antenna engineering, or for those students who are who are willing to design the antenna and take antenna as their this topic, actually, I would strongly encourage you to ask why you have such kind of antenna, and why the antenna can work or radiate at multibands or reconfigurable in such a way. This is very important. This is the first point of view. And the second point, when we're talking about the future of antenna, I think the bottleneck somehow I call it the bottleneck of engineering. And antenna engineering is somehow come from the fact that the wireless communication has become so mature, especially from the first of 1G to 2G and to 3G and now to 4G LTE or whatever. This has become mature antenna, and the antenna is an independent part. But the independent part also means like it is just a part of it. It is not no more than a part of the whole communication system. But actually, I think antenna has some more add-on values, and these add-on values are those who we are engaged, and we should emphasize we refocus our strengths to put on it. For example, I think we are going to integrate the antenna with something others. For example, with the circuits, just like me, and I will introduce my work in the tomorrow morning. And also, you can integrate your antenna with some other circuit like the filter called the filter, or the antenna with some specific application, or such like the medical application or vehicular application or something else. And I think this is the best way we antenna guys could find a new way. And this way they could eventually to make it to hit the industry and hit the academic with innovation and with some new thought in the future. This is my opinion. Thank you.
Mr. Robert.
Good afternoon. I'm Dick from the dais and the participants. I have a few points. One section for the students and another for faculty members. From the point of view of the students, the way that probably the future of the antennas lie with the applications. So for civilian applications, as rightly said, it is in the wireless domain. And not just cellular, beyond that also there are going to be many applications. Recently, the Honeywell CEO was there in our campus. He was talking about the in-building solutions and probably the need for different antennas for automating many of the systems already existent. We're going to replace it in a huge way. This $1 billion market is going to be there. There are a lot more innovative antennas which are required in that particular domain. And as Professor was telling, the standards are really getting improved every day, and probably newer type of antennas are really going to be there. And in military applications also there are many requirements that the defense sector are projecting. One such thing is recently people are talking more about conformal antennas for specific applications. Probably, as rightly said, the multifunctional multiband operations, sort of a wideband operations sort of an antennas. So this all would mean that we need to first think about the application and then look for antennas and then the technologies. So obviously, we were asked to design some miniaturized antennas recently by Texas Instruments. When the size that they gave, we started looking for different types of technologies. So we looked at fractal and different types of antennas we were looking at. At some point of time, we got stuck, and then beyond that, miniaturization doesn't look from our point of view, not possible. Then we started entering into some literature, and then there we saw magnetodielectric as an option. So which means that the future of antenna, in my opinion, lies with material science also. we need to really look at material science as a major domain, where material science with the traditional antenna technologies, if you mix it, there are plenty of opportunities there. Then obviously, every one of us have told, I also reiterate, students need to really look at analysis as an option. Don't look at the softwares and the black boxes, which will never take us further. Maybe immediately required, we can get satisfied, write a thesis, submit it, publish. That's beyond. But if you really want to be an antenna engineer, understand. Professor Garg was yesterday talking about the FTDD wonderfully. Today, Alphones was mentioning a lot more about the details. So we need to really understand, and then using the software is not an issue, but then you should know the limitations. So obviously, if you want to be a consistent antenna engineer in the future, maybe this is also required. From the faculty point of view, I have a few things from my personal experience would like to share. One important thing is that all those who have worked tremendously, who have contributed to antenna engineering, are becoming older and older. So probably there are plenty of opportunities for young teachers to come up and start doing active research academically or sponsored wise. So most of the Indian opportunities lie there for the teachers. So having said that, if you want to be a real good teacher in antennas, and then you would like to promote it further, obviously you need to really look at from concept to product. Can we really build a product? So all over the world, wherever people are successful, maybe they have converted from concept to product and then made it very big. A typical example is the IMST by Dr. Ingo Wolf. He's a typical professor that contributed so much, a fellow of IEEE, and then he started making products, and there are plenty of products in the market which, including the software empire, they have made it. All of us can definitely do it. So we are also getting older, probably there are much more younger teachers who are there who can definitely do it. And you need to really think on modeling, analysis, optimization, fabrication, testing. So end-to-end, how we could really do it is what is. It is not just as teacher if you live. You will have to really go beyond it and do it, and for which there are plenty of opportunities now. And we at our place also have experimented that, so that I will share it offline if somebody wants it. So I conclude here.
I am Somsekhar Rao from JNTU Hyderabad. I have been associated with the teaching of the courses related to antennas, starting with electromagnetic theory, transmission lines, antennas, microwave engineering, radar systems, satellite communications. We used to take these courses in a regular fashion, semester after semester, so that you are in touch with the students regularly and you know their deficiencies, and you will be able to correct them during the undergraduate level itself, and thereby creating an interest to a certain extent, or whatever extent it is possible, so that it will be easier for them to take a master's course in the related area. Unfortunately, the present day scenario is, I have been discussing this with some of my colleagues also. Most of the students or teachers or scholars, correct me if I am wrong, I will accept it, are tending towards digital and digital only, if not VLSI design, if not an embedded system or a microprocessor controller. Given a choice, most of the people will enter into these areas rather than an area related to antennas or electromagnetics. It appears the scenario is same at various institutes and universities. I am trying to get feedback on various places also. So in this background, that's what I told Dr. Patnaik also. When a conference or a workshop related to antennas is being conducted, I felt very happy to be associated with this. Somehow I missed the opportunity of attending the previous courses. There was some communication gap, we didn't get the information. But I am really happy to be associated with this. One thing that I would like to bring up in notice of the scholars is that in the present day scenario, quite a good amount of simulation tools are available. Many methods, computational techniques and electromagnetics, books are available, papers are available, but very few people are entering into these areas, but they are utilizing the tools beautifully. Welcome. When we were in the MTech or just passing out MTech, entering into the research area, even to design a simple rectangular microstrip patch antenna, we had to use a transmission line model or a cavity model. No tools were available at that time. So we have to go into the rigorous numerical techniques to ultimately design the antenna, get the L and W, and work for the resonant frequency of interest, and then try to fabricate that antenna. That itself was a exercise. And then to test it, we need some network analyzer or a good microwave bench. What is the scenario now? All these things are very much available to you. Simulation tools are available, HFSS, IE3D, FICO, CST, Microwave Studio, whatnot, ideas. So many simulation tools are available. But please remember, most of them are optimization procedures. They will not give an insight into what is happening inside the numerical method unless you show some curiosity to learn what this method is, how it is programmed, and what are the limitations. Are there any limitations coming out of convergence criteria? Are there any limitations because of singularities? Are there any factors that are coming into pictures which we do not know but take them by default and accept whatever it comes? And ultimately, when the simulated result is very nearer to the experimental results, we are happy, not knowing well whether the simulated result is correct or not. Now this has to be justified. Just because simulated result is nearer to the experimental result doesn't mean that your simulation is correct. Maybe -2 + 2 has become 0. That's a different issue. But when you are using simulation tools, please satisfy yourself whether you are able to use these tools successfully to such an extent that you can justify your coding procedure. And I advise you, please write your own code, whether it is MATLAB code or CLab code, instead of downloading the code from somewhere else. If it is not out of the way, I will quote one instant because I would like to share some of my experiences. One of my students was working on these aspects, and he brought it to my notice. Sir, I was searching internet for related papers. I found out this. One student has written, master student, I am working on smart antennas. I am going to touch up that feature. It has not been discussed. I am looking for a code for LMS method. Anybody has the code, please send it to me. This is the information available on the net from 4 or 5 people who are doing their master's program. I found it very odd. What is there to write a code for LMS method using MATLAB? It should not take much time. Then I asked him, will you write? Sir, it will take some time, sir. No, you have to write, I told him. Ultimately, he has written, that's a different issue. But given a chance, he has the tendency to use somebody else's code. This is the feature some of our students are adopting. We try to curb these practices. We try to develop an interest for them to write their own code for simulation to the extent possible, to check whether these simulated results are exactly in unison with the experimental results, and then verify whether these two are accurate or not. If not, it is their duty to justify. That means not alone the student-teacher combination, to justify where the things went wrong. So in this context, I would like to again bring it to the notice that if it is possible, each college or each institution or each organization should have at least one simulation tools, one vector network analyzer, preferably going up to 13 gigahertz or 14 gigahertz, so that X-band is taken into account, so that you can develop the optimization procedure and finalize the model on the tools, whatever is of interest to you, and then test it on the vector network analyzer. Why I am saying X-band is, in the conventional microwave engineering, most of your students at undergraduate level and PG level, they do experiments in X-band only. So those experiments can also be transported onto the VNA utility. So if such a case is there, your organization will definitely give permission to you, even though a VNA is costly. But it is a feature that one should have in every organization, so that they can develop their own small lab, one tool, one testing facility. If it is still more complicated, then please take the help of peer groups. But with this, you can definitely venture into the area and you can do more than what you have expected to do before you started your work. And why I am saying simulation tools is, again, this is my experience in the university. 10 years back, there was hardly 1 out of 100 theses, PhD theses I am referring to, coming into the area of electromagnetics or antennas. After tools have come, whether it is good or not, people are using the tools. Supervisors are forcing them to learn certain analytical techniques linked to the tools. And the scenario is there is a tenfold increase in the researchers that are working in the antennas area. Because earlier they were afraid of, the moment we write wave equations, Maxwell's equations, boundary conditions, gone case, they are lost. Now, we are allowing them to do with experimentation with the tools first, though it is not the right procedure. Once they get attracted, then pull them into the area of field theory, let them do some analytical technique also, justify their results with field theory and analytical techniques to the extent possible, and then couple it with the mathematical experimental results. So this is one which I would like to advocate. And the second feature that I would like to touch upon is research related to smart antennas. I was thinking before coming to this conference that there will be few papers on smart antennas. Maybe there will be some papers from the research scholars who will be presenting at the later stages. Why I would like to touch upon this particular group is that earlier the groups are 180 degrees different. People are on the digital side, they feel that they have got nothing to do with antennas, and people on antenna side, they will not be allowed to do something on the digital side. Now those barriers are gone. The stage has come when antenna design is to be linked with the digital signal processing aspects also, especially in the angle of arrival estimates, beamforming techniques. And with these techniques coming into picture, the utility of antennas, even for a DSP person, the knowledge of antennas and the information about antennas is becoming a must. And the areas are no longer separate and distinct, they are coupled now. You need to have a knowledge of signal processing to enter into the smart antenna area, and vice versa. But vice versa for them, it is still a troubled area when you say antennas. But for us, I think it is not a troubled area to enter a little bit into signal processing and to pull it into the antenna domain. People have done, and quite a good number of papers have come related to the areas in smart antennas, LMS techniques, RLS techniques, conjugate gradient, matrix inversion. So many techniques are available. Quite a good amount of information is available in the literature also. And you can even build the processor accordingly on the DSP side. I can test the procedures. Lastly, I would like to say only one thing. The antenna field is a ever evolving field. Dr. Alphones has beautifully demonstrated novelties related to leaky wave antennas and the other aspects, starting with omega beta diagram. And that is what I was telling him. Will there be omega beta diagram in your discussion? He said yes, there will be. That will be the first part with which I start with. Now, where up to it has gone. So there is no end to the working areas, and this is what we tell. The beauty of the electromagnetics is, even though the Coulomb's law was found in 1785, Gauss law in similar range, 200 years or 250 years or over, the concepts are still good. They will be good after 200 years or 400 years. Applications will be different. That is not the case with the digital systems. So let us be happy with our concepts and fundamentals which are going to be with us, which are going to be our bread and butter throughout our life and in the near future also. Such is the beauty of electromagnetics. And fortunately, in most of the cases, unless you enter into Faraday devices, you are going to be in the linear area of interest. All the areas, all the equations are linear equations. So your knowledge of linear algebra, matrices, and other things, coupled with analytical geometry, numerical methods, will be helping you in a beautiful way, and your mathematical abilities will definitely be put to test when you are entering into the area related to antennas and development. This is what I would like to bring it to your notice. Thank you for that.
Thank you, Professor Rao. Okay. Now, whether I summarize the opinion of the experts or I put it as my own experience, it's the same thing, that a lot of research in antennas is being worked out through simulators. And the main point which has been emphasized is you may use simulators, but try to develop the physics of the problem. And once you know the physics of the problem, it can be used for modeling, analysis, and design. That is the basic thing which is missing right now. In fact, my experiences with some of the, I've been doing review for a very prestigious journal. And most of the papers I get, they are for ultra-wideband antennas. And I find that most of these papers, they are something like a product design. So if you ask an engineer in an industry to develop an antenna with some specifications, it is something like that. It doesn't provide you, at the most it will carry out some parametric studies, and based on then simulation, etc., and then finally work, fabricate it and test it, and they try to publish it. But this type of papers, which doesn't help the users, either in the physics or in the design, I don't think they have any archival value. So what we need to do is, whether we learn it through the simulators or otherwise, we should try to develop the physics of the problem as well as which could be used for modeling, analysis, or design. And the main difference, why it is happening like this, that why the link is not there, that you are given the specification or you start with some specification of the antenna, use the simulator, come out with the product, but that in between information which we are trying to emphasize, we need to generate. Why it is not being generated is that maybe most of our researchers don't have the proper foundation in electromagnetics or antenna engineering. That could be the reason. But at the same time, I find it very encouraging that this time so many researchers are there who are working in the antenna area, and they are very enthusiastic also. But if I go back to 10 to 15 years back, I could just count the number of persons who are interested in antennas. Thanks to the simulators or the easily availability of the simulators, that there is so much of interest in the antenna design. With this one, I would say that whosoever is doing the antenna design, etc., they need to fill this gap. With these words, now I think the expert's opinion is closed. Now I'll open this forum for the audience. Please ask your question, address it to me, and then I'll address your query to the relevant expert. That's the modus operandi will be there. Now it goes to the audience, please.
My question is to Mr. Alfonso, sir. How can we utilize the metamaterials in the antenna array designing?
Yeah, can you repeat it?
Sir, how can we utilize metamaterial structures in the designing of antenna array?
Okay.
Yeah. So, I mean, you want to use it for phased array antennas?
Sir, apart from mutual impedance reduction, means how can we utilize the metamaterial structures in the designing of antenna array? Apart from the metamaterial, suppose we are using the metamaterial structures to reduce the mutual impedance between the elements, or maybe increasing the gain or bandwidth. So I'm talking about in that terms, means how we can improve the gain and bandwidth of antenna array by using the metamaterials.
Okay. You can make it in the feeding network if you can introduce these metamaterial concepts. You can control the phase shifts in a very compact structure way. So I don't think you can increase the bandwidth of the phased array antenna by introducing this, because this can provide a certain bandwidth, but the whole antenna structure, the type of antenna that you're going to use, that's the final element which is going to be one which decides the overall bandwidth. So you can control the phase shifts or the phase controlling way in a very compact structure.
So my second question is, I didn't get the feel of the opposite direction of this BG and BP, group velocity and phase velocity. Means I'm not getting the feeling of this concept, means the group velocity and phase velocity are opposite in the metamaterials.
Okay, when you've seen, that's what the omega beta diagram, as Professor Somshekhar Rao mentioned. If you bring down to the omega beta diagram, you can get a complete picture. That's what most of the students or the young faculty don't do that, because they are quite satisfied with all these simulation tools. That doesn't give the dispersion characteristics. When you look into the dispersion characteristics, the left-handed materials, always I draw in the positive side, but actually it's a mirror reflection. So it comes on the left-hand side. So when you see that the phase velocity, how do you calculate the phase velocity? It's omega over beta, but it is in the left-hand side, so the minus beta side.
So mathematically it's okay, but I'm talking about the feeling, means there is any natural example of this which can represent this.
Okay, so you want to have the physical meaning of that. So when you have a positive right-handed medium, the phase advances like this, right? So in the left-handed medium, still the energy propagates in this direction, but the phase is retarding. It's a compensating. So that's the difference between the right hand and the left hand.
My second question is with to Mr. Professor Rao and Professor Das regarding, sir, in the microwave lab, we are using the X-band clustron, and the students are using the CRO. So, and most of the manuals are representing that we are using the CRO. So I think there should be no use of the CRO, because we are using the X band, and we are showing the modes analysis in the lab, and we are giving the concept that for the microwave we are using the analysis of the S parameters. So when we come into the Viva part of the students, when we talk about the instrument, they told that we use the CRO as a component in the microwave lab. So I think that CRO should not be there in the lab. Generally, they see that DC output of the crystal detector is in that CRO. So they should use the VSWR meter to measure the modes analysis in that. So I just want to ask why the previous manual are using the CROs in that lab manuals. This question to Mr. Rao sir and Professor Das sir.
There is no hard and fast rule why you should not use, but VSWR meter is preferred. VSWR meter is nothing but a 1 kHz tuned amplifier. So it also works in the 1 kHz range only. So that way, the output of the scenario, when it is observed in the CRO, they may be able to see the shapes. But VSWR meter is the best preferred one. Unfortunately, most of the conventional local made VSWR meters are going bad very quickly. Either the meter becomes quite noisy and the needle becomes quite oscillatory, that you will not be able to measure the VSWR. So
Mr.
people are sometimes stopping the use of VSWR meter even if it is there, because they are not able to use it properly and going to the conventional mode. You can measure even the output DC current also. But VSWR meter knowledge is compulsory and mandatory for a microwave engineering student. How the minima are obtained in the slotted line, how the sample is there, how the electric field is sampled, how it is converted into the DC, what are the various scales of the VSWR, expanded scale, normal scale, what happens. The knowledge of the VSWR meter is mandatory for the microwave engineering student, whether he uses CRO or not.
So how you will means compare this digital VSWR meter is coming? This digital display is there for the VSWR reading, means an analog part.
I don't know how good they are.
Actually, I have
In terms of usage,
yes, sir. I have asked how
I would advise the use of even a power meter, because they will be able to utilize the knowledge of how power is being measured at micro frequencies. That knowledge is also essential for them while using it in the laboratory. So in addition to the VSWR, conventional VSWR meter, with the knowledge of the power meter, they will be able to understand the proceedings much more beneficially and correctly. And a network analyzer will add flavor to the situation. If not at the undergraduate level, at least at the postgraduate level. Measurement of S parameters.
Sir, my question is for Professor Garg. Sir, using FDTD method, we can model the patch antenna, and different researchers proposed different methods to model a coaxial field to excite the patch antenna. Sir, could you suggest any simple and accurate way to model coaxial field for patch antenna using FDTD?
Could you please ask your question again? Can you state it? I think
Sir,
we are talking about the modeling of the coaxial field or what?
Yes, sir. For a patch antenna using FDTD.
What they raise, there are different method of modeling the coaxial field, and different authors they propose different methods. So, can you suggest one such method which is very simple and can be modeled easily, accurately for coaxial field in FDTD?
See, the thing is, if you look at the literature, as you said something about that there are various opinions or various explanations are there so far as coaxial for the connector is there for the patch antennas. There are some simple models as well as there are very complex models, and naturally it will affect the accuracy aspect of it. The simplest model could be that you have this coaxial connector, you have a center conductor which projects, maybe if you are doing it from the back side, then the center conductor projects through the substrate and touches the upper metallization of the antenna. That center conductor could be modeled as a simple inductor, series inductor. That could be the simplest model as such. And the size of the inductor will depend upon the thickness of your substrate. The larger the thickness, the larger will be the inductance value. That could be the simplest model so far as you can say the modeling of the coaxial connector is there. But the thing is that naturally it will lose the accuracy, and I think, yeah, there will be, in addition, if you want to go to the rigorous modeling of this one, when this center pin of the coaxial connector, it attached to the metallization, there is a junction there, which is a sort of a T-junction. I am talking about the feeding of the patch antenna from the ground plane side. So there is a T-junction between the patch metallization and the center conductor. And there at this T junction, you have to take into account the effect of the discontinuity also. So that way, if you want to model it analytically or based on the simulation results, the more accuracy you want, the model is going to be more and more complicated. Does it answer your question?
Sir, is it necessary to model the outer conductor also?
No, outer one is is in contact with the ground plane.
Yes.
There is no need to model it. It is only the effect of the center pin that has to be modeled in terms of the associated inductances and capacitances as well as the junction effect between the center pin and the top metallization. Okay?
Okay. Thank you, sir.
So I have one question.
Yeah.
Normally we are developing number of linear antennas, and I am seeing that material information are not usually available at W band. So, say I am designing a lens at W band. Material information for the lens is not available, not as such the lens that its dielectric loss, etc., not available at W band. What to do about this material characterization?
I don't think, in my opinion, anything can be done in the sense that if you want to characterize any material, you have to do the measurement. There's no other way. And whatever the information is available at any frequency or any type of material, so you find it in the commercial softwares, they give you the dielectric constant, loss tangent, etc. as a function of frequency. That is mostly based on measurements only. I don't think only after you have done the measurement, then you can model it in the form of a simple expression or a complicated expression. There is no other way that you can model, no way to model it. This main thing is that you have to measure these characteristics.
But what I am saying, my intention is to know that in case of modeling or whatever you are saying, the commercial software are giving the data for this dielectric loss tangent at whatever it may be at low frequency. I have seen that usually data are available up to 10 gigahertz. Even the data are not available at 35 gigahertz, and you cannot expect that data at W band. I have searched a lot of data, a lot of information in IEEE digital library. I have not yet got any information in the W band as far as material dielectric loss tangent, these things are concerned.
Yeah, I think the reason could be.
Why I am thinking that whether any measurement possibility is existing, conventionally available, but whether this instrumentation, this thing are available at W band.
So I think the reason seems to be why this information is not available at high frequency, or talking about the W band, etc. First of all, the research is quite limited at those frequencies, especially in country like India. Maybe if you go to US and Europe, there's a lot of work going in those frequency bands. Secondly, the reason could be that the commercial software you are talking about, they may not have a very good accuracy at those frequencies. And even if they provide you some information about the data about the material characteristics at those frequencies, the output result, the results which you get from the simulator may still not be very dependable, maybe mainly because of their own inaccuracies in the simulation process. So putting a very accurate value of the material characteristics won't be of much help unless you improve your simulation.
Even normally available your RAM size workstation that doesn't help. So for the normally we believe on doing the theoretical calculation. Now in this, what we have seen, that even if you are calculating this thing, because the dielectric loss tangent are not usually known at say W band, the whatever you are doing, the gain is falling. This is leading to a reduction of gain.
Yes, quite possible.
That way, I have some data, I have generated this way some data, that if you are doing something at W band expecting this, you are getting this, the reduction in gain because of this dielectric loss tangent, some excessive values.
I don't think anything can be done about it unless you try to measure these material characteristics yourself and use it there in the design. There's no way out.
Sir, excuse me, sir. My question to Dr. A.L. Das, please.
Pardon?
My question to Dr. A.L. Das.
Yeah.
Can you please talk forward? Yes, sir. I will speak loudly, sir. So my question is little different from the technical one. It may be related, not actually different, but somewhat related to the technical one. Yes, sir. So myself, my name is V.S. Gangwar. I am working in LRT DRDO Bangalore, sir, as scientist D. So my question is like we are discussing how to create the interest among youngsters in the field of macrowave technology. So like you are mentioning that in case of antenna, technology has grown up from dish to DVF. In early days, 35 or 40 years back, we used to have a dish antenna. Today we are having a DVF technology, as you mentioned earlier. DVF or sparse array technology or shared approach technology. So as you know that in case of DVF technology, the antenna designer not only we are limited with the radiating element design, we are going to from RF to IF domain, including R or front end and high power amplifier, LNAs, filters, radiating elements. So while doing so, why we need to do this? As I understood that we need to have a good noise figure of the system, as well as we need to meet today's requirement, radiated loss requirement. We need to find the multiple beams together. We need to have a safe beam requirement. So to meet all the requirements, we need to have a DVF technology. The next question is, we have the DVF technology. We can dislodge we can form the beam in digital domain rather than having the beam in RF domain. How to measure that? Because whatever instrument we have, RF instrument, they cannot understand the digital data. For that, we have to read the RF only, macro frequencies only. So these kind of what I feel like how many audience are there where we are aware that this DVF technology, how many are we are aware of the DVF technology is no, I think so. Very few will be available of DVF technology. And then how to measure the digital beam function antenna? So
You must,
yes, sir.
you must put your mic little away because it's not clear, audible. And then ask one question at a time. Do not mix up everything together.
Okay. So let me conclude this. The technology has grown up, but what we are studying today in our educational institute, whether it is IIT or NITs, whether this being taught in the institute is getting meet the today's technological requirement, or if we are able to upgrade that or not. So that is the questions. Like how many educational institutes today are talking about the DPM? Yeah, sir, you mentioned the DPM technology. Yes, sir. Sir? Yes, sir, exactly. Yes, sir. Sir, it is but my question is whether it is updated to the industrial requirement, today's requirement.
Today, whatever is saying, when I read the audio in we hardly had anything.
Yes, sir.
That stage of time, to 35 years time, it is a reward to a large that electronic beamforming array and all this.
Sorry.
Electronic
Hello, excuse me, sir.
digital beamforming array is so it has taken a long time.
Now, these are the industry requirements of this active career. So, if you are not doing a distance, you can say ideas there. Technology is little evolving, and the issues also need to change themselves.
Yes, sir.
For all these other things, all these work need enough expertise in the particular field.
Yes.
So fundamentally, in the IITs or NITs or any other educational institution, it is essential to introduce this concept of electromagnetics, antennas to the students. They must understand the basics. That is a fundamental requirement. If you are through this one, with your own ideas, you can move forward for designing of anything.
So what I felt, I am doing my PhD also from IIT BHU. So what I felt, there is still a gap persisting between the educational institute and the industry, what industry demand today. Since it is open forum, so let me ask this question.
I have a point answer for this. Probably this is my opinion. Whatever that is required for an industry, it will not be possible for an educational institution to teach in total.
Correct, sir.
It has to be sort of a seamless integration from the college to the industry. That is what you want.
Yes.
Because you can teach digital beamforming now, maybe next technology will come, everything cannot be done.
Exactly, sir.
But as an engineer, the definition of engineer is the ability to face a problem and solve it. So towards that, the concept of electromagnetics, the concept of digital signal processing or digital whatever that you say, that has to be taught in a manner where you can face the problem and solve it. So if an educational institution supports that as a basis, then it is all right. Only problem is, as Professor was mentioning, there are many institutes where these sort of high-end equipment are not there, or they are really, it is difficult for somebody to procure everything and keep it. So that's why Patnaik sir was mentioning that there must be a common sort of a facilities people can go see, share and visit. So unlike the digital areas, at least in electromagnetics antennas, the basic concepts are still the same and still we can really learn it better. If you learn it better and get into the industry, then definitely you can do it. So if you want one-on-one matching, it may not be possible.
I agree with you, but my concern is like let at least should have that. We should be aware. Students should be aware of the.
That is why these sort of forums are really useful. IEEE or other facilities where you are exposed to certain things, you can visit and things like that could really be done. And people like you who are really concerned, you are working in LRD, you should go back to your institute and address the students, tell them that this is what is the transformation that is required.
Exactly, sir.
That is really will be useful.
So what I mean to concern, like we can convey the message to the few people once we go back to the respective institute or industries.
Correct.
And we should be in the position to pass on the information to the youngsters so that they can be motivated to the microwave technology.
Yes.
That is the
That is exactly what is required. And as
okay, sir.
Sir, good evening, sir.
Just let me find out how many questions are there so that
Only
we
one,
can
sir.
raise your hands. How many?
Raise your hand.
1, 2, 3, 4, 5, 6, 7, 8, 6, 9. Okay.
Sir, good evening, sir. I am Dr. Vijay Sagar.
I'll take 4 questions maximum. 1, 2, 3, 4. Yeah. Okay. And the rest of them can discuss with the expert.
Hello. Hello.
I think I'll take
Sir, I am Dr. C.
two questions I'll take, and the rest of the they can discuss with the experts. They will have a lot of time to discuss with the experts at tea time, etc. Maybe the first question from there.
Dr. C.H. Vidyasagar, I am from JN Government Polytechnic, Hyderabad. I would like to contribute to the research in the microstrip area, microstrip antenna.
I have done in the research in the wireless communication. I want to extend my microstrip antenna in biomedical imaging, like to replacement of X-ray or CT scan. So it is useful to the benefit of rural area. Can you extend this is a microstrip antenna to the replacement of X-ray? Because of it, the microstrip antenna is a low-cost antenna. It is a same as the microwave imaging.
Okay, let me answer it indirectly. You are raising the same question as I have been discussing with some other researchers over here. In fact, they have been discussing with me, not me, I am discussing with them. That they say that they are either working in that area or they want to work in that area. That they want to use the microstrip antenna arrays or microstrip antennas for modeling of the biological system. Already you know that MRI system is there, microwave imaging system is there, which is basically a image processing problem. And the mechanism is somewhat different, not although also that is also at microwave frequencies, but they inject some chemical or say material through which they try to measure the molecular resonances, and from that data they through an image processing they try to model the whatever the tumor or anything like that is there. In fact, I don't have any experience in that area, but looking at the interest, I'm just trying to make out, and most probably these people have been using the RF in this manner, that use a lot of antennas in a 3D fashion, collect the data, and from this data collection, they use the image processing technique or you can say the modeling technique to generate the material characteristics of the tumor or anything like that you are trying to do. But main thing over here is that if you want to use any of this information for medical diagnostics, the information you are generating that should be unique in the sense there should not be any ambiguity. Because say for example, if you look at it as a inverse scattering problem, in inverse scattering there are many possible solutions. And what you are saying could be one of the solutions. And if you say that this is the only solution and that's not the true picture, then it will create a false alarm. So especially if you want to use any technique for medical imaging, the solution should be unique. And most probably you can remove the ambiguity and make the solution unique only when you have a sufficient amount of data and you process it properly. That's what I think.
Thank you. Thank you.
I'm working on reconfigurable antenna.
Anyone from that side? Anyone? Yeah. Okay.
My question is, I would like to work in the field of terahertz antenna. Could you please suggest me how we can start work in the field of terahertz antenna?
I am not there. I am there.
And sir, the next question is, sir, is it necessary to have some knowledge about photonics for working in the field of terahertz antenna?
Yeah.
Okay, on the terahertz side, I think whatever the literature so far is all on the graphene antennas. The main problem is the fabrication. As you mentioned in the last night, you need to understand the quantum physics. So, without understanding quantum physics, you cannot go with the design of that. And the terahertz antennas, the radiation efficiency is all very poor. So far, whatever they reported, radiation efficiency is less than 20%. And they try to use it for, already the Samsung has tried, Samsung Korean company. They want to have chip-to-chip communication through the terahertz antennas. They already demonstrated it. High bit rate, the terabits range, but they use graphene antennas for very short range communication, chip-to-chip communication. But otherwise, I think for academic purpose, I think one can try it. CNT, carbon nanotube antennas, or graphene antennas, single wall tube, multi-wall tubes. There are a lot of avenues to explore.
Sir, can we use substrate integrated waveguide for the terahertz antenna? Can we use substrate integrated waveguide for the terahertz antenna? No. So far, I haven't seen it, but. Okay. As I have listened from study. The last question, please. The last question. Sir, as I have listened from study that it is necessary to work. It is necessary to start from the basics. That means most of the people work in the software, and we don't have good knowledge about the basics. Is it possible to basics apply in terahertz or not? Basic EM theory will apply in the terahertz or not?
Yes, of course. You need to because the terahertz range is basically bridging between the millimeter wave and the optical spectrum, right? So you need to have understanding of both quantum physics as well as electromagnetics.
Thank you, sir.
Okay, ladies, one minute.
So my question is to Professor Rao. Sir, till now mostly smart antennas have been used on base stations. So could you please throw some light on the use of smart antennas in handheld terminals or mobiles?
Smart antenna part, and I believe that this is a very openable field, because not many industries are working and they are relying on, with blind eyes with the ready-made available antennas. So we want to know if we are good into system designing or into FPGA or digital system designing, how we can use this knowledge to transform into smart antennas. Believe me that we are working on RFID, we are working on wireless sensor network, but again, for any antenna, we are depending on other side. Can we use this particular knowledge to transform this into smart antennas, which can be designed locally or which can be designed in a local? I've seen IIT is doing something good job. So if they can help us in designing something of that sort, so that industry can be benefited. And believe me, there's a huge requirement for such kind of technology or product which can be really change the whole market scenario. And so it is right from the education to industry to market. So if you can throw some light, because this is a very important topic which you shared, and I was about to ask you, sir, I thought let me finish it up after the forum. But if you can include that part also, it will be really help us.
Will you please repeat your question?
So my question is that till now mostly smart antennas have been employed on the base station side, not on the handheld terminals or mobile terminals. So issues like antenna size and all do not play a very important role in that case.
So to the best of my knowledge, smart antenna is not used in the cell phone or mobiles.
So will it be used in future?
It requires an array configuration of at least 5 antenna, 5 elements.
Yes, sir.
And that much amount of space is not available on a conventional cell phone. Even if you take a normal smartphone, 6 or 7 microstrip patch antennas here, but not a smart antenna, not on the cell phone, not yet at least.
Yes. Thank you.
And with reference to signal processing applications, I am working on the antenna side. I confess my limitations from the signal processing point of view, but people are working together. DSP people are coming in unison with the antenna people, and combinedly the work is going on in different areas. I can give one person's name right now who is working in our department. He has his own fabrication of a small 5-element sensor array for DSP purposes in his house. He is a signal processing man. He has limitations from the antennas, that's a different issue. But this is being tested now. He is doing it on his own, and the test is being made at an industry in a confidential manner, limited to that particular industry only. There are works related to this, but as I said, people have to come forward, signal processing people as well as antenna people. Right now, the two are distinct regions. In the forthcoming 4 or 5 years, I think people with the knowledge of both will be essential and will be coming into picture. Isolatedly, your requirements may be met with from some organizations. I cannot definitely say which organization, which person is working in that area right now. But as you said, it is one of the most needed technology of the hour.
Sir, I'll request Professor Professor Guang Ma from Taiwan. He works in integration of circuits with antenna. His specialization is integration of circuits with antenna. That is active antenna. So
his question is related to smart antennas.
That FPGA integrations or the antenna on chip, that concept, I think he will be the right person to answer. I request Professor Guang to answer on FPGA integration or circuit integration to antenna to this man's questions.
She asked about having smart antennas on mobile phone. Why do you need a smart antenna on mobile phone? The mobile phone is supposed to have an antenna which is omnidirectional. You don't require a smart antenna to get it maybe omnidirectional. The answer to your question is you don't require it. As you look at what is your requirement, then look for that. If you don't need an antenna, smart antenna, why you are going to spend money on that?
NFC enabled mobile phones. So in NFC enabled mobile phones, there has to be some antenna to identify the NFC enabled tags. So is it the same antenna which works for NFC also, or is it going to be separate antenna for? So the same antenna can work for NFC also. That is a separate question. My question is now the smartphones which are NFC enabled in smartphones. So you have an NFC enabled tag by virtue of which you can identify which particular tag this is. So there is the same antenna for both, for communication as well as for this, or there has to be some different antenna. It is the same antenna for NFC also and for communication also.
Some phones, Nokia has come out with some phones which are using 2 or 3 antennas. But mostly it's same.
But I feel since NFC works on 13.56 megahertz, and normal communication signals works on 866 megahertz. So how this is going to, that is again a great question.
Like multi-band antenna, you use the same, so when you say same antenna, it's same structure. Like you are using mobile phones with different applications. Each application has different frequencies, but you use one antenna, one structure, which is working at different frequencies.
So both frequency bands can be solved by one.
Physically it is one image, electromagnetically it is operating on different frequencies. Physically it is one image.
Okay. I think it is time to wind up this session because Professor Patnaik is getting restless. He has to start the next session. So we thank you for your interest in this session, and rest of the questions you can discuss with the experts individually. And looks like that there need to be another session like this to take care of the rest of the audience. Thank you very much.